Chapter 8, Quantities in Chemical Reactions. I skipped the first section. Can't remember why. Read through it, but there won't be anything on it on the test. Okay, so making pancakes. Hopefully everybody had breakfast. So what we're going to talk about here is the numerical relationships between chemical quantities in a balanced chemical equation. We've now talked about how to write the equation, how to balance it, and the different types. Now we're going to look at amounts. And looking at the numerical relationships is called stoichiometry. So that's a big new word for you there. Stoichiometry. We can predict how much product will get made by looking at how much reactant we start with. So I told you that those gas evolution reactions are like the ceiling fans of house cleaning. Okay, this part is like washing the dishes. Okay, washing the dishes is something that you really just have to get to or you're not going to have anything to eat off of, right? So this is important. This stuff is really, really important. So let's think about making pancakes because this process is similar to what you do when you use a recipe. So let's think about a very simple recipe for pancakes. Don't try this at home because it won't work. It's too simple. But a cup of flour plus 2 eggs plus half a teaspoon of baking powder. Mix those together and cook, and you get 5 pancakes. And here's in pictures. A cup of flour, 2 eggs, half a teaspoon of baking powder. You get 5 pancakes. Okay, we talk about a recipe. We understand that, right? Because even if you don't cook, you've seen people cook at least, right? We can predict how many pancakes will come out based on how much starting material we have. If we start with 2 cups of flour and 4 eggs and a teaspoon of baking powder, how many pancakes could we make? 10, right? And that's what we're doing, but now with chemicals. So if we have 2 eggs and plenty of everything else, we can make 5 pancakes. Because if you ever made a recipe where you had exactly the right amount of every single ingredient, I haven't. There's always something. I mean, you're going to make one recipe of pancakes and you buy a dozen eggs, right? So you use 2 of the eggs and there's 10 eggs left over, right? You don't use up all your flour. But there's always one thing that says, oh, well, you can't make any more. So we'll be talking about that. But we can look at these relationships. If I have 2 eggs, I could make 5 pancakes. There's a ratio. 2 eggs to 5 pancakes. That's going to be a conversion factor. For every 2 eggs that I use in my batter, I can make 5 pancakes. If I use 4 eggs, I can make 10 pancakes, right? If I have 8 eggs. Okay, so let's look at how we might write this down. If I have 8 eggs, how many pancakes? Well, I know that I can make 5 pancakes for every 2 eggs. So the eggs cancel out. Here's dimensional analysis again. 8 times 5 is 40 divided by 2 is 20. 20 pancakes. Now, many people can do something like that in their heads, which is awesome. It makes sense to you because you've made pancakes or seen pancakes made before, or you can visualize it. But when I tell you we have 8 moles of hydrogen and how many moles of water can we make, you freak out. Okay? That's why we need to learn how to write this down. When we write it down, then the units are going to tell us what to do. And so it's not that bad. Yeah? Okay. Let's see if we can get to the, let's see. let's go back. So looking at this recipe here, is something like that, and it's asking you how many conversion relationships?
Yeah.
Okay, so we just looked at the relationship between 2 eggs and pancakes. You also have a relationship between half a teaspoon of baking powder and 5 pancakes. For every half a teaspoon of baking powder, you could make 5 pancakes. You have a relationship between cups of flour and pancakes. And then you also have a relationship between flour and eggs, between flour and teaspoons of baking powder, between eggs and teaspoons of baking powder. So, say you're making pancakes for the football team, and you have 2 dozen eggs. How much flour do you need to use up all the eggs? How do you figure that out? Well, let's do it. 2 dozen eggs. How many eggs is that? 24 eggs. So 24 eggs, and I want to know how much flour I need. So I have flour up here, that's measured in cups, and I have eggs down here. I look at my recipe and I see that I need 1 cup of flour for every 2 eggs. 1 cup of flour for every 2 eggs. That means I need 12 cups of flour. You can actually use this in your kitchen. If you need to scale a recipe up or down, or you want to make the most of that one ingredient that you don't have enough of. Does that make sense? So in this chemical equation, there is a lot of information hiding, right? We can look at a relationship between 2 of the reactants, between a reactant and a product, or if there's more than one product, we can look at relationships between the products. Does that answer your question? So I think that's the end of that section.